Welcome to another session of Circuits and Networks. In today's class, we are going to deal once again with node analysis, and we are going to treat this as class 3. And what are the results which we are going to obtain with node analysis, we'll compare with mesh analysis. For that, I have selected the following circuit. So this particular class will give us a clear picture of how to apply node analysis and how to evaluate node analysis by taking a proper LCM and obtaining the final result, and then comparing the result with mesh analysis, which is our favorite method. So let us start with the problem. Here you can see we need to obtain branch current in 2 kilo ohms in this particular resistor using circuit analysis. So for this, we are selecting node analysis as solution 1. With this node analysis, whatever the answer which you are going to obtain across 2 kilo ohms, that is the value of current, later we are going to compare the result with mesh analysis. So let us solve it. Node analysis. So we are going to apply KCL at node V. So we are going to find out the node V. So you can see I have taken the circuit once again and I have identified node V. Now this node is assumed to be at higher potential, and the rest of the parameters which are connected to this particular node are assumed to be at least potential. So the ground potential we are taking as 0, and the branches which are connected to this node is 9 volts in series with 1 kilo ohms. Another branch is 2 kilo ohms, which is connected directly to this node V, and you have 4 kilo ohms in series with 6 volts. So how do we do that? We are going to start with V minus 9, that is the voltage difference, divided by 1 kilo ohms. So 1 kilo is nothing but 1000 ohms is equal to 1 kilo ohm. Okay, plus V minus 6, V minus 6 by 4000. 4k indicates 4000 plus V by 2000 equal to 0. So with this, I'm taking V outside. So how to select a proper LCM and how to solve the problem in a easier way, that is what it is explained in this particular example. So you can see I have selected V outside. So V 1 by 1000 plus V by 4000 plus V by 2000. So I have taken V outside and I have taken the constant values inside, which is equal to, here you can see we have minus 9 by 1000. So it goes to the right hand side, it becomes 9 by 1000. Then you have minus 6 by 4000. So I'm taking 6 by 4000 on the right hand side. So with this, I'm taking V by 1000 outside and 1 by 1000 outside in both the cases, thereby eliminating the 1000 values. Then I can take the LCM on the this particular parameter as 4. So V times, you have 1 here, so it becomes 4 plus 1 plus 2 to the 4. So this proper LCM you have taken on this left hand side, which is equal to 1000 for cancelling the denominators. You have 9 plus 6 by 4. So 4 into 9 is 36. 36 plus 6 is 42. So 42 divided by 4. So in both the cases, denominator 4 value goes off. So you have V, which is equal to 42 by 7, which will give you the value as 6 volts. So once we get the value of 6 volts, so node voltage is known. That is what is major requirement. Then we need to calculate the current in 2 kilo ohms. So according to Ohm's law, V is equal to IR. So you need to calculate the value of current in 2 kilo ohms. So it becomes I is equal to I across 2 kilo ohms is equal to V by 2000. So 6 by 2000, which will give you the value as 3 milliamperes. And in your calculator, you can see you are going to obtain the value as 0.03 amperes, or simply can be written as 3 milliamperes. So this is how we solve the node related problems. So you can see how properly we have selected the LCM, how we have eliminated the K values, and we have simplified in an easier way under node analysis. Now we know that the value of current in 2 kilo ohms is 3 milliamperes. We have to cross check our analysis with mesh. So the same circuit is selected and we are selecting current I1 direction as clockwise. Since you have minus and plus on the left side of the circuit is 6 volts, sorry, on the right side of the circuit is 6 volts. So I'm taking anti-clockwise as I2. So I1 clockwise, I2 anti-clockwise. So with this, I'm framing the mesh equations under loop 1 and loop 2. Once you apply under the loop 1, that is applying KVL, you're going to get minus 9 plus 1k I1 plus 2k I1 plus I2. Why I1 plus I2? Because you can see I1 is flowing from this side to this side and I2 is flowing from this side to this side. So 2 kilo ohms is superimposed by I1 and I2. That's why 2k I1 plus I2 is equal to 0. Simplify this equation, we are going to get as 3k I1 plus 2k I2 equal to 9, or you can write 3000 I1 plus 2000 I2 equal to 9. Frame this as equation 1, and the same analysis I'm starting from the this part of the circuit. So applying KVL to loop 2 anti-clockwise. So minus 6 plus 4k I2 plus 2k I2 plus I1 equal to 0. Simplify this equation. I'm going to get 2k I1 plus 6k I2 equal to 6, or 2000 I1 plus 6000 I2 is equal to 6. Just simplify these two equations. We are going to get the value of I1 is equal to 3 milliamperes and I2 is equal to 0 amperes. Once we obtain the value of I1, I2, we are interested to know the value of current in 2 kilo ohms. So I across 2 kilo ohms, when you take the mesh analysis, it will be equivalent to I1 plus I2. Unlike the previous case, under node analysis, we got the value of I2 kilo ohms is equal to node voltage divided by the 2 kilo ohms resistance. So here we are going to take loop current 1 and loop current 2, which is going to get the value as 3 milliamperes. So this is how you cross examine with mesh analysis the actual solution with node analysis. I hope you understood this approach. Let us go with another example. Obtain node voltage V naught for the circuit shown below. So you have to obtain the value of V naught across 4 kilo ohms. If at all you observe carefully, V naught positive is assigned on the upper side, negative is assigned to the downward side. In fact, V naught is parallel to 20 in series with 5k. V naught is also parallel to 30 in series with 2k. So this is the main analysis. So we are going to go with node analysis, and V naught I am framing because it is understood it's a parallel value. So I have shifted V naught to this particular node because V naught is parallel to this branch and this branch. So all are in parallel. That's why V naught I am selecting as a center node. Now it is easy for me to obtain the node equation. So you can see V naught minus 30 by 2 kilo ohms, which is nothing but 2000, plus V naught minus 20 by 5000 plus V naught by 4000 is equal to 0. Isn't that simple? Now just take out V naught on one side and taking the constant values 1 by 2000 plus 1 by 5000 plus 1 by 4000, which is equal to 30 by 2000 plus 20 by 5000. I am taking now thousands outside in order to remove the k problem, just to simplify the solution in a better way. So I'll be left out with 1 by 2 plus 1 by 5 plus 1 by 4, which is equal to 30 by 2 plus 20 by 5. So just remove the 1000 values and take the proper LCM. So I have removed the 1000 on the denominator on the both sides, and I'm going to take the LCM. So LCM which you're going to get is 20. Here you can see 2 is there. So 2 tens 20. Then you have 5, 5 fours are 20. Then you have 4, 4 fives are 20. So in fact, on the right hand side, we got 15 plus 4, 19. On the numerator of this parameter, we got as 19. So 19, 19 goes off. In fact, we not will be equivalent to 20 volts. So this is how you need to simplify under node analysis. Many students have the complications in solving the problem with node analysis. That's why in this particular class, I have approached with node analysis first, and then I am cross-checking the result with mesh analysis. I hope this will be useful for you to solve any kind of node related problems. This is a basic problem. In my next classes, I'll try to select gate related problems or engineering services related problems. And I also start with the next concept, that is transient analysis and two-port networks. So please answer in the chat box whether you are interested to know the information regarding two-port networks or transient analysis. So let us cross check our result also. So for our result, V naught has to be obtained. So we have selected mesh analysis. So I1 is taken in clockwise direction, I2 is also taken in clockwise direction. You can take the directions of the loop currents in your own way. For simplification or easiness, I have selected I1 and I2 for easy understanding. Let us solve the problem. So applying KVL to loop 1. So you can start with 2k I1 minus 30. On the path I got the value of voltage as minus 30 plus you can see we have started from 2k, then minus 30 plus 20 as it is, plus 5k. I1 minus I2 equal to 0. Just reframe this equation. We are going to get the value as 7k I1 minus 5k I2, it is equal to 10. So this we are treating as equation 1. Now apply KVL to loop 2. Then you're going to get 5k I2 minus I1 minus 20 plus 4k I2 equal to 0. So simplifying this equation will result as minus 5k I1 plus 9k I2 is equal to 20. You have 5k here now. So 5k plus 4k will give you the value as 9k. And you have minus 5k. So I have reframed this equation. So solving these two equations, we are going to get the value of I1 which is equal to 5 milliamperes and I2 is equal to 5 milliamperes. It is a fortunate case that we got the value of I1, I2 as same. What is our main interest? We need to know the value of V naught. So V naught, it is measured across 4 kilo ohms. So according to Ohm's law, V is equal to IR. We have the R value as 4K and the current value just we got as 5 milliamperes. So just applying the formula for Ohm's law and substituting the value of resistance and the current, which is nothing but 4000 into 5 milli, nothing but 5 into 10 to the power minus 3, or you can write 5 divided by 1000, which will give you the value as 20 volts. So this is how you inspect the result with one solution with another solution, and that conclusion what we have to get is whether you employ mesh analysis, node analysis, or any other method, whatever the magnitude value which is required across a particular parameter, it has to remain always the same. So in today's class, we are done with node analysis and mesh analysis, the basic related problems. This we are treating as class 3. As I told you, in my next classes, I'll be taking some of the numericals related to gate and engineering services, and also I'm planning to start with transient analysis or two-port networks. So you please comment on the chat box on which particular topic you are interested. Based upon the views, I'll see and I'll select the next topic to be explained in the next class, apart from taking the basic classes for node analysis, mesh analysis for dependent sources and gate related problems or engineering services related problems. So I hope you like my video. Please share among your friends, subscribe to my channel, and please press the bell icon for the future notifications. Thank you.